Today we're doing a few word problems from 9-8. So this first problem, we have the product of two numbers is 1. So I'm going to write givens, product equals 1. And then also I know that the squares differ by 15/4, which means like one square minus the other equals 15/4. That's what differ means. So what I want to find is two numbers, the first number and the second number. I'm going to call them x and y. So I'm going to make two equations here. First is that their product is equal to 1, so x times 1 is equal to 1. And I'm going to solve x in terms of y, so I'd have x is equal to 1 over y. Next, I would make my second equation, 1 square minus the other square equals 15/4. So let's go ahead and say x squared minus y squared equals 15/4. Now I'm going to replace x squared with 1 over y, so I have 1 over y squared minus y squared equals 15/4. So then that's 1 over y squared minus y squared equals 15/4. I'm going to get rid of both of those fractions by multiplying everything by 4y squared. So I end up with 4, because the y squareds cancel, minus 4y to the fourth equals 15y squared, because those 4's cancel. And then I'm just going to rearrange so that I have this in the proper quadratic form. 4y squared, 4y to the fourth power, etc. 4y to the fourth power plus 15y squared, and then minus 4 is equal to 0. So I'm going to factor this using the methods that I've learned. So I'm going to multiply 4y to the fourth and negative 4 to get negative 16y to the fourth, and I drop down the 15y squared. The two numbers that multiply to negative 16 add to 15 are negative 1 and 16, so I put those there. And then I'm going to fill in my box, 4y to the fourth, negative 4, I get negative y squared and 16y squared. Out of the first column there, I can take out a y squared. Out of there, I can take out a 4, and because that box with 16y squared is positive, I'm going to put a plus sign in the middle, and then I take out a 4y squared out of that row, and then a minus sign, right, because it's negative y squared, and I can take out a 1 of that last row. So then I end up with the two factors y squared plus 4 times 4y squared minus 1 is equal to 0. So y squared plus 4 is equal to 0, and 4y squared minus 1 is equal to 0. Now if I look at that first one, I realize there's no solution to that, because y squared plus 4 is always going to be positive. It can never equal 0, otherwise y squared would have to be equal to negative 4, right? And that's not possible. So I'm only going to factor the second one, right, which is a difference of squares. 2y minus 1, 2y plus 1 is equal to 0. Therefore y is equal to 1/2 and negative 1/2. But I'm actually not finished, because I need to find x and y, and x is equal to 1 over y. So I'm going to say x is equal to 1 over 1/2, which is equal to 2, and then x is equal to 1 over negative 1/2, which is equal to negative 2. So my two final solutions are 2 comma 1/2, right? I'm writing it as x comma y, and negative 2, negative 1/2. And I'm finished with that problem. I found both solutions. So this next one, if I have a rectangle with an area of 10 and a diagonal of length 5, I want to find the dimensions. So I'm going to draw this. I have a diagonal of 5, so I'm going to draw that across, label it with 5. And then I also know that I want to find the dimensions. So I've got two unknowns. I'm going to call them x and y. It doesn't actually matter where I put x and y. I'm just going to put them in those two locations for now. I'm given that the area is equal to 5. That diagonal, which I've already drawn in the picture, is equal to 5. So I want to find x and y, and I'm going to use the fact that the area is equal to 10, so x times y is equal to 10. And I also can see that I have a triangle here, and because I have a triangle, I can use that geometry to say that, well, according to the Pythagorean theorem, x squared plus y squared is equal to 25. So I'm going to take my first equation, x times y equals 10, and I'm going to set x equal to 10 divided by y, and plug that into the second equation. So 10 over y squared plus y squared is equal to 25. Again, I've just replaced x with 10 over y because x is equal to 10 over y. So I end up with 100 over y squared plus y squared is equal to 25. Now I want to get rid of that y squared because I don't like to work with fractions. So I end up with 100, because the y squareds cancel, plus y to the fourth equals 25y squared. So I'll just rearrange that so that I have it in the sort of normal quadratic here. It should be y to the fourth there. I'll change it in a second. Y to the fourth minus 25y squared plus 100 equals 0. So I'm going to factor this. Now, I really didn't have to do this method. I could have just factored it normally, but, I just decided to do it this way. So if I multiply the last two terms, I get 100y squared, and then, they need to add up to negative 25y squared, so I end up with negative 5y squared and negative 20y squared. Those are going to add up to negative 25 y squared, and multiply to 100 y to the fourth. And then I am going to do my box. Again, this is kind of unnecessary. I don't actually know why I did it this way, but a lot of you like to do it this way even if you have no leading coefficient. So I'm just kind of showing how you would do it with that. So I end up with y squared minus 5, y squared minus 20. You should pause the video and try that on your own if you need a little more time. So I know that both of these are multiplied and it's equal to 0, right? So I'm going to solve so that y squared is equal to 5 and y squared is equal to 20, which means y is equal to plus or minus 5, y is equal to plus or minus 2 root 5. That's the square root of 20. Now, you may know that my dimensions are rad 5 by 2 rad 5, right? Because I'm going to eliminate those negatives because they don't make sense, right? Because we're looking for the dimensions of a real shape. But you also may, plug in rad 5 for y and end up with x is equal to 2 rad 5. You also may plug in 2 rad 5, and then you realize that after I multiply top and bottom by rad 5 over rad 5, I end up with 10 rad 5 over 2 times 5, and then I end up with just rad 5. So you notice that x and y were actually interchangeable, right? So we only take the positive solutions first of all. We're not going to take the negative solutions because they don't make sense. And then I end up with just dimensions 2 rad 5 by rad 5. It doesn't actually matter which one was x and which one was y. If I say that the dimensions are rad 5 by 2 rad 5, that's the exact same thing, right? So we're just going to write one of them. So let's take a look at this one. We have Bob put 2 ladders on a building, one that was 20 meters long and the other one was 15 meters long. The base of the large ladder was 7 meters farther away from the building than the smaller one, but both ladders reached the same height. So I'm going to draw these 2 ladders, the purple one and the green one, and they're reaching the same height, right? And I also know that one of them is 15, that's the shorter one, and I'm going to label that on the green one, and then I also know that the longer one is 20 meters. I also know that this little distance here, right, the 20 meter one is 7 meters farther away from the base of the building, so I'm going to label that as well. So I need to mark out some unknowns. There's an unknown x and then there's an unknown y, but really I only want to find x. So I'm looking for x and I want to solve an equation, solve multiple equations. So the first thing is that I have 2 triangles, right? So x squared times y squared is equal to 15 squared. But also, what I might realize is that x squared times plus y plus 7 squared is equal to 20 squared. That's the second bigger triangle where the base is y plus 7. So I'm going to take the first equation and I'm going to solve it for x squared. So x squared is equal to 225 minus y squared. And I'm going to plug that x squared into the second equation. So it's 225 minus y squared plus y squared. I'm expanding the y plus 7 squared plus y squared plus 14y plus 49 is equal to 400. The y squareds cancel there, and I'm left with 14y is equal to, I'm going to do 400 minus 225 minus 49, and I end up with 126 right there. And then if I divide both sides by 14, then I end up with y is equal to 9. So y is equal to 9. And what I can do is I can plug 9 into the first equation where x squared plus y squared is equal to 225 or 15 squared. And x squared would be equal to 144 once I subtract 81 there. So therefore x is equal to 12 meters, which was what I was looking for. Good luck on your homework and have a great day.